Okay, problem 527 from your Mastering Physics assignment has a woman pushing a cart up a ramp at a 13-degree angle. She's applying a horizontal force, but the cart's going up at an angle. That's what makes this problem a little bit challenging because you have a lot of angles involved. But because the motion is up the ramp, because you've got this acceleration on that angle, the cart's on the ramp, we're going to rotate our perspective so that all of our forces are either parallel or perpendicular to the ramp. So what we know is that it's an 8-kilogram shopping cart, and we know it has an acceleration up the ramp in the direction of the, parallel to the ramp of 1.5 meters per second per second. So with that information, before we draw our force diagram, knowing, oops, got some remnants here. Before I do anything, I want to make sure I write down everything that is given in the problem. I have an 8-kilogram mass. I have an acceleration of 1.50 meters per second per second. And if you remember, our equation for the unbalanced force looks like this. The unbalanced force over mass equals acceleration. That's easy to rearrange so that your unbalanced force is just equal to mass times acceleration, both of which they've given me here, and here. So I've got 8 times 1.5. I know what my unbalanced force has to be. It is 12 newtons. And it's in the direction of the ramp, parallel to the ramp. So remember my acceleration, I'm going to draw it way up here because I don't want it to get confused with a force vector. My acceleration is up the ramp at that 13-degree angle. The woman's force is a horizontal force. That's not looking so good. Is a horizontal force like this. So that's the force of the woman on the cart. So she's not pushing along the ramp, she's pushing horizontal. So we have to find a component of that that is parallel to the ramp. So we got to draw ourselves a little force diagram down here. I'm doing a different color. So I know I've got the Earth's force on the cart. That is straight down. Remember, the Earth always pulls straight down. It doesn't have anything to do with the angle of the ramp. The center of the Earth is always, vertically down from any point that you want to pick. The support force of the floor, remember, is on at a 90-degree angle to the surface. So this vector, this force vector, the force of the ramp on the cart, is actually already perpendicular to the surface. So we don't have to do anything with that vector. Then I've got the woman's push force, which is the horizontal one right here. This is the force of the woman on the cart, and that is horizontal. So I've got two forces here in this problem that are neither perpendicular nor parallel to the surface, so I have to find components for both of those. I don't care so much about the perpendicular ones. I'll draw them in here, but I know this thing is balanced in that direction. So I'm going to move my label here to get it out of the way. That was the force of the Earth. All right. I really don't care about these perpendicular components because they will end up offsetting each other, and the cart will be balanced in this direction, up and down. The cart is unbalanced up and down the ramp. But I have to find components, as I mentioned, of the red vector here, the woman on the cart. So I have to find a component of that that is parallel to the surface and a component that is perpendicular to the surface. Again, I don't care so much about that one. I know that this vector right here is going to be the sum of both the gravity vector pushing into the ramp and the part of the woman's horizontal force goes towards pushing that cart into the ramp. You can imagine pushing horizontally, you're going to be pushing the wheels slightly into the ramp, mostly up the ramp, but some of that force is pushing into the ramp right here. So the unbalanced force is the difference between, let me just use another color here because I'm going to erase it, is going to be this guy here minus this guy here. That's the unbalanced force. Obviously, the component of her push force parallel to the surface has to be bigger than the Earth's force wanting to pull it down. Otherwise, she wouldn't be accelerating it up the ramp at 1.5 meters per second per second. Okay, so let me go ahead and write that little equation. The unbalanced force is the difference between, I'm going to call this the force of the woman on the cart in the x direction. I'm going to call x the direction that is parallel to the surface. And I'm going to call the Earth's component force in the x direction FECX. So it's going to be the woman's force on the cart minus the Earth's force on the cart down the ramp. This is a negative direction right here. Okay? So we know the unbalanced force is 12. We know the Earth's force we can find because this is my 13-degree angle right here. And if the cart has a mass of 8 kilograms, that means the Earth's force on it from our lab that we did earlier this year, you guys know it's basically 10 times that. It's 80 newtons. 9.81 is close enough to 10. So the force of the woman on the cart in the x direction minus 80. Okay. Times, oops, that's why it wasn't looking right to me. We have to multiply that times sine of 13 degrees. Okay. So 80 times sine of 13. Let me do my calculations here. I get 17.996, basically 18. So it's going to be 12 equals in the x direction minus 18. We add the 18 to both sides. We get the x component is 30 newtons. That is this component. That's not our push force. Okay, that's the x component. This is also 13 degrees if you want to do the geometry here. You know, this is a horizontal force right here. This line right here represents the floor is horizontal. This is parallel to the ramp. This blue dotted vector right here, obviously this is the ramp, so a line parallel to the ramp and that are going to be at the same angle, so 13 degrees here, 13 degrees here. So now we have to, since this is the adjacent leg, and we know the length of the adjacent leg, you know, cosine of 13 is equal to adjacent leg over the hypotenuse, which is the hypotenuse in this case is a woman's push force. That's got to come up here, and cosine of 13 is going to go down there. So the horizontal force is 30 over cosine of 13, which makes sense because the hypotenuse always has to be longer than the leg. So 30 divided by cosine 13, I'm going to get, basically 30.78. And usually they want it to 2 sig figs in Mastering Physics, so I'm going to call that 31. Now I'm going to go back to Mastering Physics here, type in our answer, hopefully we got it. Oh, rounded differently. I guess at some point in that problem I rounded off probably when, well, this was close to 18. I'm not sure where that rounding error was, but certainly when I get 30.8 I'm going to round up. But they accepted the answer. Hopefully that makes sense to you. If you don't have, if you have a question, please feel free to ask in class after you watch this Monday night or Tuesday. Okay?